contradiction will always be given P implies Q, right? Which this will be, this means that when we are proving a contradiction, we are going to assume this. We are going to assume, so here's what you're going to do here for contradiction. You are going to assume P and the negation of Q. So this is what you're going to assume, right? So let's see. I think we have some questions there on proof by contradiction. We can try some. On proof by contradiction. Let me try to do this. Proof by a contradiction, right? So I'll just add this question somewhere here. Yeah, you see the proof by contradiction says that we are going to assume P and Q. So first we need to come here and say proof. We do the same thing here. We start the same way. We say proof, we say P, we say Q. You said it, and our P is this one, n squared plus 1 is odd integer. And then our Q is n is even integer. So we're going to assume here, when you're proving proof by contradiction, we're going to assume P and the negation of Q. So it's like I'm just direct substituting. What is P? P is n squared plus 1 is odd integer. You see right? And I say and. How I interpret this sign is read as and. And the negation of Q, I'm going to say n is odd integer. And then what do we mean by odd integer? This one we're going to leave it, right? We're only going to define one. We only define one of it. What do we mean by odd integer? We're saying that n is also 2k plus 1 for some k element of an integer. You see right? Then now we take this and try to show. We take this and try to show. We say we're always going to take the one that is easy to show with, right? So take n squared plus 1 is also, we know that n is 2k, so this is 2k plus 1 squared plus 1. And this will be 4k squared plus 4k plus 1 plus 1. So whatever we get here, remember we assumed that n is odd, right? And we assumed that n squared plus 1 is odd. We must find that one of these is the opposite. So that's why we say it contradicts. You see right? So if we check here, when we continue to solve, we're going to get 4k squared plus 4k plus 2, which this will be equal to 2k squared plus 2k plus 1. And we found out that this is indeed the opposite. We say where m is equal to 2k squared plus 2k plus 1, which is an element of an integer. You see right? I say therefore n squared plus 1 is even. But what did we say on our assumption? We said that n squared plus 1 is odd. You see right? So this is contradiction. We say which contradicts our assumption. You say, right, which contradicts our assumption. And then we say thus, this pen, and it's giving me trouble, guys. Then we say thus. Now we copy and paste the question as it is again. If n squared plus 1 is odd, then n is even. Thus, if n squared plus 1 is odd, then n is even. Then we're done. Is there any question here, guys? Before we can attempt the second one. Is there any question? I can even try to do this. I can even try to do O2 and put it like this so that you can see the entire question on the same page, right? Is there any question here? Based on this first question which we were asked. I think if there's no question, I can say this. I can say, can you please try to do C? Please try to do C. I'm also gonna give you this one. I'll give you like 7 minutes to do C. Then this will be it will be the last one for the contradiction. If I want to see if you really understand. If you don't understand, it means that we're going to do more questions, bit more, before we can go to the last one, which is proof by cases. But proof by cases, guys, that one is simple. Even if you can look at it yourself, you realize that we just did something like that in methods of proofs. You say, right? So let me end this.